What if the ground beneath California's coastline isn't as solid as you think? What if the very edge of America is slowly slipping downward, inch by inch, year by year, and almost no one noticed until the satellites saw it from space with more low rumble? Because right now, scientists are watching something unsettling unfold along the Pacific, and the question is no longer if it's happening. It's how fast. A satellite drifts silently 400 miles above Earth. Below, California's coastline glows in digital relief. Color gradients pulse across the screen. Blues, greens, yellow, then streaks of red. Red means motion. Red means change. Red means the land is moving. Cut to cliffs along the Pacific, crumbling in slow motion. Waves slam against their base. Again. High tide creeps farther inland than it did last decade. A coastal road buckles. A seawall fractures. A measuring instrument blinks, recording another fraction of a millimeter lost. And you realize something chilling. The ocean isn't just rising, the land is sinking. For years, scientists have monitored sea level rise along California's coast. That's not new. What is new is what orbiting radar satellites have quietly revealed. Using ultra-precise instruments capable of detecting changes smaller than the width of a coin, researchers have discovered that parts of California's coastline are not stable. They're subsiding. That means the land itself is lowering in elevation, not collapsing overnight, not dramatically, but steadily, relentlessly, and in certain areas faster than the experts expected. This discovery didn't come from guesswork. It came from satellite interferometry, a technique that compares radar images taken months or years apart, measuring microscopic shifts in Earth's surface. When scientists layered these images together, they saw patterns that shouldn't have been there. Entire stretches of coast drifting downward, some zones sinking a few millimeters per year, others far more. Individually, those numbers sound small, but along a coastline stretching more than 800 miles, small changes add up, and when land sinks while seas rise, the risk multiplies. The data came from multiple satellite missions operated by international space agencies. They weren't looking for disaster. They were mapping terrain stability, tracking earthquakes, studying tectonic motion. But hidden inside the datasets was another story. Along portions of central and southern California, radar signals revealed gradual downward deformation. Not uniform, not random, specific zones, certain coastal basins, low-lying urban corridors, harbour regions, wetlands. In some places, the ground dropped only a millimetre per year. In others, 5. In rare pockets, more than 10. That might not sound dramatic, but 10 millimetres per year means 4 inches in a decade. 40 inches in a century. That's more than 3 feet. 3 feet of lost elevation before you even factor in rising seas, low pulse. What startled scientists wasn't just the motion, it was the pattern. Subsidence wasn't limited to one isolated location. It appeared in clusters, some near major cities, some near vital infrastructure, some near areas already vulnerable to flooding. The satellites showed subtle bowl-shaped depressions forming over time, like invisible fingerprints pressed into the Earth's surface. And unlike earthquakes, which strike suddenly, this movement was slow, quiet, persistent, the kind of change you'd never feel under your feet, but one that satellites never miss. Researchers double-checked the data. They compared years of observations, filtered atmospheric noise, verified instrument accuracy. The signal remained clear, consistent, real. Something was happening to California's coast, and it wasn't a glitch. Why it's happening? 6 to 9. So what could make an entire coastline sink? The answer isn't one cause. It's a combination of forces that are acting together, like gears in a machine you can't see. First, geology. California sits along the boundary of massive tectonic plates. Those plates don't rest. They grind, they shift, they flex the crust. Some regions are naturally sinking, while others rise. It's a slow tectonic dance that's been happening for millions of years, but tectonics alone doesn't explain the patterns scientists observed. Another factor lies underground, water. Specifically, groundwater. In certain coastal regions, fresh water is pumped from underground aquifers to supply cities and agriculture. When too much water is removed, the soil above can compact. Grains settle closer together. The land surface lowers. Oh, it's like removing air from a cushion. The more you take, the flatter it becomes. Then there's sediment. Many coastal plains are built on ancient river deposits. Loose layers of sand, silt and clay. These materials compress over time, especially under the weight of buildings, roads and infrastructure. Urban development adds pressure. Gravity does the rest. And finally, sea level rise. While rising water doesn't directly push land downward, it magnifies the effect, because if the ocean climbs while the land drops, relative sea level rises faster than expected. From a resident's perspective, it looks like the ocean is advancing, even if half the change is happening beneath their feet. Individually, each force is manageable. Together, they can reshape coastlines. Imagine waking up one morning and realizing your city is a few millimeters lower than it was last year. You wouldn't notice. Your street would look the same. Your house would stand exactly where it stood before. But over time, subtle shifts become visible. Drainage systems struggle. Storm water lingers longer after rain. High tides creep closer to sidewalks. Salt water begins infiltrating freshwater soils. Wetlands migrate inland or disappear entirely. Infrastructure designed decades ago suddenly sits closer to sea level than engineers intended. Highways along the coast face increased erosion. Rail lines risk instability. Seawalls designed for past conditions confront future oceans. In some communities, a subsidence can worsen flooding during storms, because when land lowers, it reduces the margin of safety. That invisible buffer between civilization and the sea shrinks. Wind sound. For coastal ecosystems, the stakes are just as high. Marshes depend on precise elevation relative to tides. If land sinks too quickly, vegetation can drown. Habitats vanish. Bird migration routes shift. Fish nurseries disappear. Nature doesn't negotiate with elevation. It obeys it. For millions of Californians living near the coast, the implications aren't immediate catastrophe. They're gradual transformation. But gradual doesn't mean harmless, because slow change can sneak up on societies. The way rust creeps across steel, unnoticed, until it matters. Scientists studying the satellite data stress that subsidence isn't new. What's new is our ability to measure it with extraordinary precision. Researchers from geological surveys and universities monitoring coastal deformation say the findings highlight the importance of long-term planning. They emphasize that sinking land can amplify flood risk, especially when combined with storm surges and climate-driven sea level rise. Some experts caution that ignoring subsidence could lead to underestimating future coastal hazards. Others note that monitoring technology is improving every year, giving communities more time to adapt. The message from the scientific community isn't panic, it's awareness. Because the earlier changes are detected, the more options exist to respond. So, should this discovery alarm you? Not in the way headlines might suggest. California's coastline is not about to vanish into the ocean. There is no sudden collapse coming tomorrow. Subsidence is typically slow, measured, trackable, but that doesn't mean it's harmless. Think of it like a ticking clock rather than an exploding bomb. The danger isn't instant destruction, it's gradual escalation. If land continues to sink while seas continue to rise, risks compound over decades, planning becomes harder, costs increase, and decisions made today determine resilience tomorrow. The real threat isn't motion, it's ignoring motion. Right now, satellites still circle above Earth, watching. They don't sleep, they don't blink. They record every millimetre the coastline shifts, every fraction the land sinks, every subtle signal humans can't feel. And as you stand on solid ground, looking out at the Pacific, it may feel permanent, unmoving, eternal, but far above you. The instruments see the truth. The edge of the continent is changing, quietly, slowly. And whether we notice reality or not, the coastline is still moving,